So this is 4.1 and looking at the three types of linear systems graphically. So if you take a look at page 260, you see you have two parallel lines. So these two parallel lines do not intersect, so this tells us right away that there is going to be no solution to these two equations. And so that means it's a parallel line, and we call parallel lines with no solution. We actually call it inconsistent. It's an inconsistent system, meaning that we cannot find a solution to that. Then we also have case B, where we have two lines intersecting like we've just seen. That'll give us one solution. So when we are looking at intersecting lines, we get one solution. We call that consistent because we are expecting an answer, and it is independent because of the fact they are intersecting. Okay, they are independent, independent of each other. So then we look at case C, where we have two lines coincide. Every point on this line represents a solution, meaning you have a line and then you have another line that lands right on top of the original line. So basically it's identical lines. Okay, you have infinitely many solutions. We still call it consistent, but it's dependent on each other, so it has to be the same. So let's take a look at some examples of that. So if I wanted two lines that were parallel, like we learned in the past, that would mean I could make one up. We could say it is y equal to 2x plus 4. And then we have another one, y equal to 2x plus 10. These are both parallel lines, so we have no solution. So if we try to solve that, we're not going to get a solution. Now, if we are looking for ones that are one line on top of the other, like we saw in this previous problem, where you have the purple line where everything's landing on top, that could be something like this. We would maybe make it as x plus y equal to 6. And then we have 3x plus 3y equal to 12. These are really the same line, because if I put these both into slope-intercept form, this would be y equal to negative x plus 6. This one here, I would move the 3x, so it would be negative 3x. So that's 3y equal to negative 3x plus 12. Divide everything by 3, and so I get y equal to negative x plus, it's 4. So dang it, this is going to give me two parallel lines. So I wanted to do an example where it wouldn't do that. So that 12 probably should have been not 12 but 18. So if this was 18, 18 divided by 3 would give me the 6. So these two lines, x plus y equal to 6 and 3x plus 3y equal to 18 are identical lines. So because again I could take out the 3, couldn't I, to give me the x plus the y equal to 6. And so that means these two lines are the same line, which means they have infinite solution, and so they are consistent and dependent. And so these are the three examples that I wanted you to see and to make sure that you understood.